Virtual memory. What is virtual memory? Let us first know about the history of virtual memory. The concept of virtual memory was first developed by German physicist Fritz Rudolf Kunsch at the Technische University Berlin in 1956 in his doctoral thesis Logical Design of a Digital Computer with Multiple Asynchronous Rotating Drums and Automatic High-Speed Memory Operation. To allow for multiprogramming and multitasking, many early systems divided memory between multiple programs without virtual memory, such as the early models of the PDP-10 VR registers. In the 1950s, all larger programs had to contain logic for managing primary and secondary storage, such as overlaying. Virtual memory was therefore introduced not only to extend primary memory but to make such an extension as easy as possible for programmers to use. To allow for multiprogramming and multitasking, many early systems divided memory between multiple programs without virtual memory, such as early models of the PDP-10 VR registers. Virtual memory is a common part of operating system on desktop computers. The term visual memory refers to something which appears to be present but actually it is not. The virtual memory technique allows user to use more memory for a program than the real memory of a computer. Virtual memory is a memory management technique that is implemented using both hardware and software. It maps addresses used by a program called virtual addresses into physical addresses in computer memory. Main storage, as seen by a processor, task appears as a contiguous address space. Virtual memory uses both hardware and software to enable a computer to compensate for physical memory shortages, temporarily transferring data from random access memory to disk storage. Mapping chunks of memory to disk files enables a computer to treat secondary memory as thought were main memory.
Importance of virtual memory. Virtual memory is a critical component of modern computer systems. It is a memory management technique that allows an operating system to use a combination of physical memory and secondary storage to simulate a larger amount of available memory. So, the first importance is increase effective memory. Virtual memory enables a system to run programs or processes that require more memory than is physically available. It allows multiple applications to be loaded into memory simultaneously, even if the total memory requirements exceed the physical RAM capacity. This increases the effective memory available to the system. Second importance is effective memory allocation. Virtual memory allows for efficient memory allocation and management. The operating system can divide the virtual memory space into fixed size blocks or pages and load only the necessary pages into physical memory. This approach optimizes memory uses as only the required portion of application are loaded while the rest remains on the disk. The third importance is it allows computer to use more memory than physically available in system's RAM. Next is it makes more efficient use of available system resources. Next is virtual memory provides a mechanism for protecting memory from unauthorized access. It allows large program to run on system with limited physical memory.
Now we will see the types of virtual memory. The first type is paging. Paging is virtual memory technique that separates the memory into sections called paging files. When a computer reaches its RAM limits, it transfers any currently unused pages into the parts of its hard drive used for virtual memory. The computer performs this process using swap file, a designated space within its hard drive for extending the virtual memory of the computer's RAM. By moving unused files into its hard drive, the computer frees its RAM space for other memory tasks and ensures that it doesn't run out of the real memory. Then another is the segmentation. Segmentation is another method of managing virtual memory. A segmentation system divides virtual memory into varying lengths and moves any segments that aren't in use for computer's virtual memory space to its hard drive. Like paging tables, segment segment tables track whether the computer stores the segment in memory or a physical address. Segmentation differs from paging because it divides memory into sections of varying lengths, while paging divides memory into units of equal sizes. The paging hardware determines the size of section, but user can select the length of the segment in the segmentation system. Segmentation is often slower than paging, but it offers the user more control over how to divide memory and make it easier to share data between processes.
Have you ever tried to run a program on your computer and received an error message saying that there is not enough memory available? This is where virtual memory comes in. Virtual memory is a technique used by the operating systems to simulate more memory than is physically available. When you launch an application, it is loaded into your computer's memory. If the application requires more memory than is available, the operating system can move less frequently used portions of memory to the hard drive. This frees up the space in physical memory, allowing the application to continue running. When the application needs the memory again, the operating system can move it back into the physical memory. Virtual memory is managed by the operating system, which divides the memory into small sections called pages. While virtual memory can slow down a system if used excessively, it is a critical component in allowing computers to run large and complex applications.
Hello friend, here we show the advantage of virtual memory. The advantage of virtual memory. First one is by using virtual memory, many application or program can be executed at a time. Then the memory has been limited space, but you can increase and decrease the size of virtual memory by yourself. User can run larger program then have a size greater than the main memory. The data which is common in memory can be shared between the RAM and virtual memory. CPU utilization can be increased because more process can be reside in the main memory. And the last one is the cost of the buying extra RAM is saved by the using virtual memory.
Hello friend, my last topic is disadvantage of virtual memory. Virtual memory, special hardware for address translation. Some instructions may require 5-6 address translation. Difficulties in registering instruction, chip microcode complexity. Complexity of OS and overhead page fault is an expensive operation in terms of both CPU and I/O overhead. Page fault bad for real time. And my last point is thrashing problem.
Thank you from Team D3.